Hello students, here's how you're going to do homework number 13. First, you're going to download the Master Stats workbook. Enable editing, and then enable the content. Now, I know that I will need to go to creating confidence interval for means. So creating confidence interval for means is this one. I'm going to minimize this one and go to the first question. So the first question is going to say, for a confidence level of 95% with a sample size of 32, find the t value or the critical value. I always keep a pencil and a piece of paper next to me, and I write the level of confidence, 95%, and I write n is equal to 32. Now that I have n, I need the t critical value, and I know that the t distribution is going to depend on the degrees of freedom. Luckily, my sheet does that for me, so I don't have to worry about anything. So in this case, I just need to find t critical. I need to change n, and I need to change the level of confidence. So n is 32, and the level of confidence is 95. Now this is t. I'm going to just copy it, and I will paste it over here. If you want to know how to find t by hand, then you're going to watch this video and you can find it by hand. I'll show you step by step how to do that. For this question, I have n equals 14, x bar is equal to 48, the standard deviation is 6. We need to find the margin of error at a confidence level 99%. So the margin of error is the one that we need here. So I'm going to go to my Excel sheet and I plug my values. X bar, I have it at 48. S, which is the standard deviation sample, standard deviation is 6. N is 14. And then the level of confidence is 99%. The margin of error is going to be this number. And it says here, the question says to round it to 2 decimal places. So I'm just going to paste it and round it afterwards. I'm going to eyeball it, and I see that it rounds to 4.83. The next question. So the next question says, in a survey, 27 people, so n is equal to 27, were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with a mean of 33, so x bar is equal to 33, and a standard deviation is 8, so s is equal to 8. Construct a confidence interval at a level of confidence 95%. We need to create a confidence interval. In this case, the confidence interval is of the form the point estimate plus or minus margin of error. If you remember from previously, we talked about the 3 ways that you can express the confidence intervals. The first way is point estimate plus or minus margin of error. In this case, we're talking about the estimated population mean, so the point estimate is going to be the sample mean plus or minus the margin of error. Another way is to write the lower bound, comma, the upper bound. The third way is to write the mean in the middle, or the parameter that we need to estimate greater than the lower bound and less than the upper bound. So those are the 3 ways that we write the confidence interval in. And this is the way represented in this specific question. So I know that I will put x bar in the first box, and I will find the margin of error and plug it into the next box. So I'm just going to head to Excel and I will change my numbers. I know that x bar is 33 from the question, S is 8, and N is 27. The level of confidence is 95%. Now all I need is the margin of error. I know the mean is 33, so that is what's going to go here, and the margin of error is going to go here. I'm going to round it to 1 decimal place, just like the question is asking me to do. And that is how you're going to answer that question. If you want step-by-step on how to compute each one of these, please watch this video. It's going to walk you through the process. As you probably know.
Hello students, in this video I will show you
you will be able to control the speed, the playback speed. If I'm going too fast for you, go to a slower speed. You can go at 0.75 or 0.5 or 0.25. It's up to you. If I'm going too slow, you can speed it up a little bit by going 1.25 or 1.5 or 1.75. Let's go to the next question. The next question is saying, you intended to estimate a population mean with a confidence interval. You believe the population to have a normal distribution. Your sample size is 10. Okay, so we know when we are dealing with the sample size, even if the population is normally distributed, we're going to, if the sample size is small, we're going to use the t distribution instead of the z distribution, just because it's going to be more accurate to estimate the population mean in this case. If the sample size is more than 30, I would say it doesn't really matter whether you use the t distribution or the z distribution, but we're going to stick to the t distribution for everything, because as the sample size increases, the d distribution resembles the z distribution, which is the normal distribution that we studied before. My sample size is 10, so n is equal to 10. Find the critical value. We need the critical value, which is the t critical. That corresponds to a confidence level of 90%. 90% is the confidence level. So now that we have the sample size and we have the confidence level and we need the t, that's all we need to change. N is 10 in this case, and the level of confidence is 90, and the t is going to be this number right here. I'm just going to copy it and paste it over here. It says round it to 3 decimals, so I'm just going to round this to 3 decimals. This is a similar question to the previous one, so I will just leave it up to you to find that answer. If you want to find the answer by hand, watch this video right here attached to the bottom of this question. In this case, we are given the confidence level in this one format, and we want to find the X bar and the margin of error. And if you watch this video, this is going to explain very well how to do that. Please remember to do the addition and subtraction first, and then you're going to divide last. So do not just plug it into Excel like you see it. You're going to say the upper bound plus the lower bound divided by 2, unless you're planning to surround the addition by parentheses. Because the thing with Excel is it doesn't really understand that it needs to do the addition or subtraction right away for you and then divides. It just prioritizes the operations as they are written in it. So if I'm going to copy this question, let me see if I am able to, and I will head to Excel. Okay, I still see the numbers, so that's okay. I'm going to put my numbers here. I see that the upper bound is the bigger number, which is 233, and I see that the lower bound is equal to 56.2. So in order to find X bar, so we know that X bar is equal to the sum of the upper bound and the lower bound divided by 2. I'm going to say equal to, and I will put my parentheses, upper bound plus lower bound, and then close the parentheses divided by 2. So that's my X bar. Now we need to find the margin of error. I know that the margin of error, I can find it from the confidence interval by subtracting the lower bound from the upper bound. So I'm just going to say, open parentheses, upper bound, always start with the big number, minus the lower bound, close the parentheses, and we're going to divide it by 2. So once we add them, divide by 2 to find the point estimate. If we want to find the margin of error, we subtract them and divide by 2. And we always write the bigger number before the smaller number so we don't get negative values. So in this case, I have X bar. And then I have, not this one, I have the margin of error. I will copy that and I will paste it over here. This is very similar, except for the format of the lower bound and the upper bound is different, or the confidence interval is different. I know that the smaller number is the lower bound, the bigger number is the upper bound, and I can answer it that way. Here, I was given the confidence interval in the form of point estimate plus or minus margin of error. And since here we're estimating a population mean, I know that the first number is going to be the mean, and the second number is going to be the margin of error. I know to find the lower bound, I need to subtract those two numbers. So let me see if I can just copy these two numbers and paste them here somewhere. Okay, now let me put them nicely. I know that the upper bound, I have the mean is equal to the first number, 832.3, and the margin of error is equal to the second number, 55.8. Okay, now to find the upper bound is basically when we add these together. So I'm just going to say the first number plus the second number, and that is the upper bound. The lower bound is when we subtract them, so the mean minus, the mean equals the mean minus the margin of error will give me the lower bound. I will begin with the lower bound. I will copy it, and I will head here and paste it in the first box, and then I will go to the upper bound. It's right here. I'm going to copy it, and I will paste it in the next box. Okay, if you notice that I made it a little bit easier for you, and I added a section here just in case you're given the upper bound and the lower bound. You can just stick the numbers in here and it will automatically compute X bar and the margin of error for you. But if it's given in the format, this format, then you need to do it by hand. Let's continue. Question number 9. Assume that a sample is used to estimate a population proportion. Find the margin of error that corresponds to a sample size 59. So the sample size, xn, is 59. And we need to find the margin of error. The mean is 29.3. X bar is 29.3. The standard deviation S is 10.6 at a confidence level of 95%. And we need to find the margin of error accurate to 1 decimal place. It says here, don't round too early. Since we're not going to do this by hand, we don't really have to worry about these instructions here. So don't worry too much about these instructions. They're just for those who are using or doing the work by hand. I know that X bar is 0.3. S is 10.6. N is 59. The level of confidence is 95. So here I need to compute the margin of error, rounded to 1 decimal. It looks like 2.8. So I'm just going to head to my homework and say 2.8. For this question, you want to obtain a sample to estimate a population mean. Based on previous evidence, you believe that the population standard deviation is approximately 54.4. So the standard deviation is 54.4. And you would like to be 99% confident. So the confidence level is 99%. And you want your estimate to be within 10% of the true population. The margin of error is 10%. So in this case, I'm going to go to the sheet right here. And I will look at the very bottom part of the sheet, which is going to allow me to find the sample size. Use the following formulas to find the sample size. So the first thing that I need to change, I know that the confidence level is 99%. The standard deviation is 54.4. and the margin of error is 10%. So I'm just going to type 10%, and this is going to be my sample size. I will copy that and I will go ahead and paste it over here. Let me just double check my work here. Okay, 54.4. 54.4. So I made a mistake right there. Copy, and I will hit here and paste it over there. I need to find the lower bound and the upper bound. Karen wants to advertise how many chocolate chips are in each big chip cookie at her bakery. She randomly selects a sample of 74 cookies, so n is equal to 74, and finds the number of chocolate chips per cookie in the sample has a mean of 14.1. So x bar is 14.1 and a standard deviation of 1.3, so s is equal to 1.3. What is 95% confidence interval for the number of chocolate chips per cookie for big chip cookies? And we need the answer accurate to 1 decimal place. So we need to compute the upper bound and the lower bound. The level of confidence is 95%. So x bar is equal to, where is the data here? X bar, where did I write it? 74, 14.1. The standard deviation is 1.3. And 74 cookies is the sample size. The level of confidence is 95%. So we need the upper bound and the lower bound. So the lower bound is this number. We need to round it to 1 decimal. So I'm just going to paste it over here, and I will try to round it to 1 decimal. It becomes 13.8. And then I will go here and I will copy the upper bound, and I will round it here to 1 decimal. So that is how you're going to answer this question. For this specific question, you're going to click on the link and you're going to follow the instructions. So the instructions says waitresses and waiters at a restaurant are trying to estimate the average tip on a given day at stat key. We're going to click on the link provided. Then we want to change the data to the data set to restaurant tips. And then we need to create a sampling distribution by running at least 6,000 samples based on their data. And we're going to find 97% confidence interval for the average daily tip at this restaurant. So we need to compute the mean and the margin of error. EBM is basically the margin of error. So I'm just going to go to I clicked on the link and I went here. You need to change this to tips, restaurant tips. Let me see, I can't see it. Restaurant tips is right here. And then you need to generate 6,000 samples. 1,000, 2,000, 3, 4, 5, and 6. As you can see here, the data is approximately normal. And I have samples. You have 6,000 samples. Now, if you notice here, we need the size of each of these samples and the mean for each sample, meaning we need the sample mean and we need the sample size and we need the sample standard deviation. So this is where we should be looking. So I know that the sample size in this case is 157. The mean for this sample is 3.849, and the standard deviation for each of these samples is 2.421. I'm going to take this information and I will head to my Excel sheet, and I am looking for the margin of error. I know that X bar is 3.849. I know S is 2.421, and I know that the sample size is 157. The level of confidence in the question was 97%. Now we need the margin of error. I'm just going to copy the margin of error, and I will head to my homework set, and I will paste the margin of error here. and the mean is 3.849. 3.849 from the question. We came up with that from the question. So this is how this question is answered. In a survey, 19 people were asked how much they spent on their child's last birthday gift. This is a repetitive question. We just need to find the margin of error. We have X bar. N is 19, X bar is 46, and the standard deviation S is 9, and the level of confidence is 90%. You will be able to do that question on your own. We answered a similar question to this one as well, so I'm not going to go over this question either. In a survey, 21 people were asked how much they spent on their child's last birthday gift. In this case, we just need to report the level of the confidence interval as the mean plus or minus the margin of error, but the interpretation is going to depend on the lower bound and the upper bound. So let me actually answer this question. N is equal to 21, X bar is equal to 48, S is equal to 13, and the level of confidence is 80%. So I'm just going to go here and plug the numbers in. We know X bar is 48, S is 13, N is 21, the level of confidence is 80%. So I'm just going to copy the margin of error. That's what I need there. The margin of error goes in the next box, and the first box is going to have the mean. The mean is 48. Now the interpretation, let me just submit this part. Okay. The interpretation of the confidence interval is always going to depend on the context, but we're going to use the lower bound and the upper bound to say that, or to interpret our confidence interval. So the lower bound here is 44.42. Let me write it down, 44.24, not 42. This is the lower bound, and the upper bound is 51.76 approximately. So this is, I know this is money. So 44.24 cents, $44.24, $51.76. Now the interpretation. Since this question is asking about trying to predict the average people spend on their child's last birthday gift, or spent on their child last birthday gift, we're going to say we are 80% confident, because of the confidence level here, that people spent between the lower bound $44.24 and $51.76 on their child's last birthday gift. Okay. So that is basically the interpretation. The interpretation is going to depend entirely on the context of the question. It's going to be different. The only thing that is always we're going to use is this format. We are confident that this happened between this and that, between the upper bound and the lower bound, whether we're talking about a proportion or we're talking about the mean. Let me add on average here, because we're talking about the mean. So the average is between this and that. It's not like they spent between this and that. Hopefully this was clear enough. If you have any questions regarding to that question, please let me know. This is a straightforward question. Again, you just plug in the numbers, plug mean here, the margin of error here. Make it a point that you round to the suggested 1 decimal place here. The next question, which of the following is correct formula for the margin of error of a population mean where the population standard deviation is not known? So when the standard deviation is not known, we're going to use the sample standard deviation. We're going to use the sample standard deviation, and the margin of error here is we're going to use the t values to estimate the margin of error, because we don't have the population standard deviation. We know that if we have the population standard deviation, that is going to be the z-scores, but since the population standard deviation is unknown, we're going to use the t distribution, and we're going to use the sample standard deviation. So the first formula is going to be the margin of error when we don't know the population standard deviation. And that's it for homework number 13. If you do have any questions regarding homework number 13, please let me know. If you want me to show you specific question in details, again, please let me know. I'll do my best to create that video for you, and I'll try to make it available to you as soon as possible. Thank you.